This section is about inequalities, and here we're introducing set notation and interval notation. So you might remember from Algebra 1 that we used inequality notation right here. So for this inequality on the number line, it represents h is greater than 5, but h is less than or equal to 10. So there's a closed dot at 10 because it includes 10, and there's an open dot at 5 because it doesn't include it. So this set notation, you're going to put in brackets, and it's h such that, and now you're going to put the inequality notation inside this set notation. This is set notation. So we're talking about the variable h. There's a bar right here, and then you write the inequality notation, but you put that in between sets. So here's how I make the sets. So that's what these outside ones look like. And interval notation is new too. So interval notation at the end can either have a parentheses or a bracket. So if there is parentheses, it means it does not include the number. So 5 is not included, just like it's not included in the open dot, just like it's not included in the inequality notation. But 10 is included, so you're going to use a bracket. So let's look for one that has an infinity. So this is h is less than 10. The set notation is h such that h is less than 10. And so now all the numbers that are included in this interval go all the way back to negative infinity. Since infinity, I'll write the symbol for infinity, it's the sideways 8. Since infinity is not really a definitive number, that's why we have a parentheses. So negative infinity is going to have a parentheses. 10 is going to have the parentheses because it doesn't include it. And I'm looking at this one right here is kind of, this was wrong on this chart. This should be a closed dot at 10. So maybe that graph was just wrong. Closed dot at 10. So h is at least 10. It's h such that h is at least 10. And we're including 10, so we're putting a bracket. And infinity, again, is going to have a parentheses because it's not a definitive number. So an open dot means the number is not included. And then the closed dot means the number is included. And with inequalities, don't forget that you change the sense or direction of the inequality when you're multiplying or dividing by a negative. So the reason that we do that is if you put these numbers in order from, these numbers right here are in order from least to greatest. So I could put these inequality symbols in between them. However, if I multiply the numbers by a negative, we'll just do -1, you're going to have 2, 1, 0, -1. I can no longer put these inequalities this way. That wouldn't make sense. 1 is not greater than 2, 0 is not greater than 1, so that's why you have to flip the inequality when you multiply or divide by a negative. So solving inequalities work just the same way as solving an equation, except for you have to be careful about changing the sense of the inequality, and you can put your answers in set notation, interval notation, and there's a graph to it. So in this case, I'm going to look at all these fractions, and I'm going to multiply both sides by the least common multiple of the denominators in order to clear fractions. So I have a 3, 4, and 12, so I'm going to multiply everything through by 12. So 12 times 5 12, so it's just going to be 5 because the 12s cancel out. 12 times 1 divided by 4 is 3. And this term, 12 divided by 3 is 4 times 2 is 8. So it's a much simpler inequality. So 8x greater than 8, x greater than 1. So set notation is going to be brackets. I'm talking about the variable x, bar, and then I'm going to use the inequality notation. Close the set. Interval notation. So this is all real numbers that are greater than 1. So the endpoint on the left-hand side is 1. It doesn't include 1, so I'm going to do a parentheses. And this goes all the way to infinity, sideways 8. And infinity is not a set number, so it's a bracket, or so it's a parentheses. So let's look at this one. I'm going to solve the inequality, do the distributive property, combine like terms, and then I'm going to subtract 8 from each side. And then when I divide by -10, I need to change the inequality, the direction of the inequality. So if I write this in set notation, I do x such that x is at least 2.8. And then interval notation, if I were to graph this, it's a closed dot at 2.8 and graph to the right. So the number starts at 2.8, it includes 2.8, and goes all the way to infinity. So more with inequalities, you can have a no solution inequality and an all real number solution inequality. So I'm going to distribute on this side. 3 times 1/6 is 1/2. Now what I have is I have the exact same thing on the right and left hand side. So I'd subtract 3x, add 1/2, and you'd have 0 is less than or equal to 0. So is 0 less than or equal to 0? Yes, it's true. So this is going to be all real numbers. This statement's always true. On the other hand, you can have over here -7x plus 12 greater than -7x plus 20. These cancel out. 12 greater than 20. That is false, so that's going to be no real solution. And number 3, a salesperson earns salary of $7 a month plus 25% of the sales he makes. If the salesperson wants to make at least $1,000 and less than $1,500 for tax purposes, write and solve an inequality to calculate the sales. So in this case, we have 2 endpoints of our inequality. This is a compound inequality. We're trying to make between at least includes it, less than 1,500 doesn't include it. So I'm trying to calculate the sales. X is going to be the sales. So the sales are going to be what I'm going to make is going to be 700 plus 25% of the sales. So it's 0.25 times the sales. So this compound inequality is an in-between. So what you're going to do to solve for x is you have to subtract 700 from the 3 sides. 300 less than 0.25x less than 800. So now I'm going to divide both sides by 0.25, which is the same thing as multiplying by 4, because this is actually 1/4, so I'm going to multiply both sides by 4. So I'm going to get 1,200 is less than or equal to x is less than $3,200. So I need to make at least $1,200 but less than $3,200 for tax purposes. Okay, so now we're going to talk about compound inequalities. And you can have a compound inequality that is an and a compound inequality that's an or. So an and means you're going to see where the inequalities overlap. So an and is where they overlap. So what do they have in common? So if we overlap an inequality such as this one right here, which starts at 1 and is greater, and it goes to infinity, and if we overlap it with an inequality that starts at 3 and goes to infinity, so this isn't this problem right here, I'm just making up a different one. We want to see what they have in common. What's the intersection? So if I look right here, what they have in common, where they overlap at, is at 3. There's nothing in common over here, so the solution would be x is greater than or equal to 3. That's where the red and the black would overlap, would be the blue. So if you wrote that in interval notation, it would be starts at 3, goes to infinity. And sometimes they won't overlap at all. Sometimes they overlap the entire time, so that'd be all real numbers. If they don't overlap at all, it's no solution. An or is everything, the entire thing that's covering it. So if this problem was an or, all the numbers that it satisfies, the black and the red together would be the black. Because the red is just a portion of the black. So the entire thing would be the black. So let's do a couple problems of these. So if I have this, I'm going to solve it separately. So I'm going to have x is greater than 6, and if I solve this one, x is less than 6. So if I graph this, x is greater than 6, I'm going to make this part black and make this part blue, and x is less than 6. Is there any point where the black and the blue overlap? Do they have anything in common? It doesn't. So this would be, in set notation, it doesn't have any answer. There's no solution. The solution is nothing works. So x such that no solution. Or, well, I'll just leave it like that. In interval notation, you'd write no solution. Because nothing works. There's no intersection. Down here, it's an or. So I'm going to solve each one. X is great, excuse me. X is greater than or equal to negative 5. Okay, so it's x is less than negative 2. So I'm going to graph negative 2, x less than, or x is greater than or equal to negative 5. So when an or is, you're looking for what is the blue and the black covering together. Not where do they intersect, but if I look from left to right, is over here shaded? Yup. Is over here shaded? Yup. Is anything over here shaded? Yup. The entire line is shaded. So that means that the solution is all real numbers. So I do x such that x is all real numbers. And then the interval notation would be it's starting at negative infinity and it's going to infinity. So right here, and then the last problem is I'm going to skip this one because we don't have enough time for it in this video.